Cancer undoubtedly possesses a tough health challenge due to its complexity of diagnosis and treatment. While researchers and pathologists continue to unravel the best treatment procedures for cancer, artificial intelligence looks set to enhance clinical procedures and a diagnosis for cancer. Could AI be the technology that will usher us into an effective cancer treatment era? Join us in today's video episode to explore AI potential in cancer cures. Let's delve in. Cancer is a disease state whereby abnormal cells replicate without control and begin to attack nearby tissues. It can also spread to other healthy tissues through blood and lymph. In the medical field, the study and treatment of cancer is referred to as oncology. According to the World Health Organization, cancer has been identified as one of the global leading causes of death. In 2020, about 20 million deaths have been recorded from different cancer cases. The most common cancer cases include breast, lung, colon, prostate, skin, and stomach cancers. Looking at these huge figures, you may be tempted to say that there seems to be no significant improvement in the treatment patterns for cancer patients. But with technological advancement and the increased prevalence of AI applications in almost all areas of life, massive upgrades and breakthroughs have been recorded in most medical approaches. So, what are the roles of these AI tools in cancer treatment? Artificial intelligence has increased the rate and accuracy with which cancerous cells can be detected at an early stage. We all know the best way to prevent these cancerous cells is by detecting them early and removing them as soon as possible. In our books, early and accurate cancerous cell identification could pass for a massive breakthrough because it will help to greatly decrease the rate of finding cures for the later stages of cancer. Intriguingly, specialized AI-based systems can accurately predict the chances of a healthy person getting cancer by identifying possible risk factors contributing to cancer development. We can go on listing the many roles of AI in enhancing clinical practices for treating cancer, but that is not the aim of today's video. Although we will still get to list more fascinating roles of AI in cancer treatment as this video progresses. Conventional cancer treatment methods are widely accepted clinical approaches to cancer treatment and cure. The most common conventional medical procedures for cancer are chemotherapy, radiation, and surgery. We will analyze each of these conventional cancer therapeutic methods, their limitations, and why artificial intelligence appears to be the possible way forward. Chemotherapy as a cancer treatment procedure is mostly applied in stage 4 cancer cases. It involves using certain medications that can target and kill cancer cells. These medications work by stopping cancerous cells' reproduction, preventing cancerous cells' growth, and simultaneously stopping the spread of these cells to other healthy tissues. Depending on the stage of cancer, chemotherapy may or may not completely cure cancer. Sometimes, especially in breast cancer cases, surgery is followed by chemotherapy to ensure that these malignant cells do not replicate again in the body. Well, chemotherapy looks good as a possible treatment procedure, but the procedure is known to be associated with a lot of stress. Being diagnosed with cancer alone could pose a big stress, but with chemotherapy comes other stress requiring you to go to the hospital often for treatment, checkups, and tests, possibly on different days. Also, chemotherapy is known for destroying healthy cells, such as hair cells. Other notable side effects of chemotherapy include loss of appetite, skin and nail changes, bruises, sore mouth, loss of blood, etc. From all we have shown you about chemotherapy, you should see the need to adopt better treatment practices rather than holding to chemotherapy in artificial intelligence. Radiation therapy, on its part, uses high-threshold radiation to kill cancerous cells and simultaneously shrink the tumors that may be associated with cancer. Radiotherapy is applied mostly when these malignant cells are at their early stages of spreading. Like chemotherapy, radiation therapy is mostly used with surgery and chemotherapy procedures to ensure accurate results. Radiation therapy also has after effects similar to those implied in chemotherapy. In addition, some permanent conditions may also be associated with radiation therapy. These permanent conditions include hearing loss, cataracts, and memory loss. Surgery is the oldest form of treatment procedure for cancer. It involves the removal of malignant cells and some other tissues that may have been compromised through surgical operations by surgeons. More often than usual, a curative surgical procedure becomes necessary when cancer is localized in a specific body part. It could serve as the main treatment procedure for a localized cancer. Surgical procedures also come with associated side effects. Its most notable side effect is the pain that comes naturally after surgery. Others include chest and breathing difficulty, wound healing problems, infections, bruises, etc. Having followed this video keenly, you should see that all the conventional treatment procedures for cancer treatment have so many limitations that may end up being fatal in the long run. Artificial intelligence seems to have recognized all these limitations, which makes it a reliable cancer treatment option in the future. Machine learning, ML, is now incorporated into cancer identification and treatment with huge potential to transform oncology. The digitization of patient data has paved the way for ML techniques. So, we mentioned digitization of patient data paving the way for cancer treatment using ML. The big question now should be, how do these machine learning techniques work? Machine learning adopts data-driven insights through which it aims to transform cancer care. With machine learning, a more accurate prediction of cancerous cells and tumors can be made, which aids in early cancer detection. In addition, ML can also suggest the best treatment plans and schedules for patients that are already diagnosed with cancer. Some commonly used machine learning algorithms include decision trees, logistic regression, naive Bayes, and artificial neural networks, ANN. All these models are applied in the prognosis, diagnosis, and treatment of cancer. Deep learning, DL, also works similarly to ML. It also makes accurate predictions by analyzing huge cancer datasets. Deep learning is rapidly evolving, having shown impressive results so far. We hope to see how far this technology goes in the long run. Some DL algorithms include convolutional neural networks, CNNs, autoencoders, generative adversarial networks, GANs, deep belief networks, DBNs, etc. Like the ML models, they perform similar functions. On its part, natural language processes, NLPs, involve the application of different computer algorithms to process and comprehend raw data that may be significant for cancer treatment procedures and utilize in advanced cancer research. Some common algorithms that use NLPs include text classification, machine translation, sentiment analysis, natural language processing, etc. Notably, the various algorithms, models, and designs listed under machine learning, deep learning, and natural language processes are utilized for specific cancer cases, not just random cases. Medical practitioners in artificial intelligence know these and are in a good position to educate us further on these models. The first step to every successful medical treatment is early detection of what may be the cause of such a diseased condition. We have mentioned the role of AI in the early detection of malignant cells, and we won't be stressing it any further. Instead, we shall be looking at other benefits we stand to benefit from when AI becomes fully adopted in cancer treatment practices. With AI, a personalized treatment plan can be drafted for cancer patients. A personalized treatment plan will remove the stress that comes with the conventional treatment procedures mentioned earlier. Most importantly, AI will be a cheaper and more cost-effective option when compared to other traditional treatment techniques. You are not only assured of a cheaper option, but you are also guaranteed a better outcome after treatments with AI. We have stressed the need to implement AI in cancer treatment. It will be out of place if we fail to recognize some factors hindering the project. One of the major setbacks to AI adoption in cancer treatment is the lack of digitalized patient data. For the best AI experience, a comprehensive digital record of patients will be required. When there's not enough data, it becomes difficult for the AI to predict, diagnose, or even suggest the origin of these malignant cells. Another concern that has been raised about the adoption of AI is that the technology is resistant to change. Ethical concerns were also raised because some patients' histories that need to be kept secret may get exposed with AI. We will be drawing the curtain at this point in today's episode. We hope our viewers enjoyed the video and understand the role of AI in cancer treatment as discussed in this video. Do you think artificial intelligence will do more good than harm in cancer treatment? Please tell us what you think in the comment section below. Finally, ensure you like, share, and subscribe to our channel to stay updated on the latest happenings in AI.